Hi again, my name's Henry. This is the second of 3 videos about the Wouse. The purpose of this video is to document my work done on the Wouse. My job was the hardware, while the software was done by Philip Grice and Charlie Kemp out at Georgia Tech. A couple prototypes were already completed with the design work done by Andy Lee when I came out here to work on the Wouse, and I'm going to show them to you. And I'm going to show you what I did to improve them in this video, and I'm going to show you how we fixed the earlier designs before to make them better. This first one right here, done by Andy, was made or printed out of ABS plastic in a MakerBot printer. As you can see there, some of it is deteriorating. The quality of MakerBot prints is not very high, so the next one that Andy decided to print was done with nylon. This one's much better quality, as you can see there. It's very durable, none of it's falling apart at all. So this is a good base for making future Wouse. Now I'm going to explain the components of the old Wouse and show where improvement was needed on it. Here's the Wouse mounted on the pair of safety glasses right there. It's just kind of snapped in. Now in order to understand how to improve it, I understand how each piece of hardware worked inside, as you can see right there when I move closer to the camera. First here is the USB port right there, or the new one. This is for charging the battery. Remember that it is wireless. Here's the old one right there. This is still the original one. A smaller one's going to fit in that hole that I showed you. And here is the battery, that little guy in there, as you can see. Finally, we have the PCB board, which is there. And then you have the laser that's on top of it that comes out of the mouse. This is mounted onto a custom piece of acrylic, which is that black stuff you can see right there, with these little machine screws that stick out on the other side. Note that the mouse buttons are not yet mounted. You can see them just sort of hanging out. This is a problem that I solved with the final iteration of the Wouse. The main problem that users had with this version is that it is difficult to adjust. The only way to adjust it, you can see, are these little screws here, here, and there. And the bump on this laser right there must be flush on your skin. So I'm going to put on the Wouse and I'm going to show you that part there on your skin where it has to be flush to. If you look more closely, it's right up in there. So basically this whole PCB there has to be easily mobile. This CAD video shows the PCB board along with a small brace that the adjustable levers are mounted to. That brace is in blue. All the components on top of the PCB board are also modeled out in it, so we can be sure that the brace can fit on top of there properly and not run into them at all. Stick those two guys together. You can see how they fit. Move that guy around a bit and see on the other side. It does go under a bit, so it does cover up the screw that holds them together. From these initial drawings, we produced a prototype, and this is it. There are 3 problems with it, however. First is that the mouse buttons are taped up with orange tape here. We need these buttons to program the Wouse to stay constantly on. This means that the laser is constantly on, so it can execute the run-stop function whenever needed, on call, and then it can signal that directly to the robot. The second problem is that these frames fit too tightly on your face, on almost everyone's faces that I tried them on, but that was easily solved just by adjusting the hinges a little bit in the CAD view for the next 3D print. And the last problem is that after trying them on a lot of people, I realized that the top of the laser needed to be angled at about 20 degrees outward for a good fit on people, which means that it's like this. This part here is down, and that part there is more up. Okay. The levers work better when they're closer together, so on almost everybody I tried, we needed this lever to be all the way down and that one to be clicked like that, which just doesn't work as well. They give a maximum tilt of about 15 degrees, so I was able to fix this problem so it fit right around that middle point if this brace is angled at 20 degrees. This part shows the mini USB port and how it fits into the main case. This is just for charging the battery of the Wouse. Got him in there. Now why don't we go take a look at the buttons. Alright. That gold piece on the far left is the little roller part of the mouse. That fits into the button casing. Now we have the two mouse buttons on their little board. And finally our two buttons which adapt on top of the old mouse buttons and fit into the case. Fit that all together there. You can see those two buttons. The right click mouse button is on the right and the left click mouse button is that one on the left. Once we fit that in the casing, we can now fit our two new buttons on top of the old ones. There's one and two. Now we have our main button assembly all together. Zoom in and get a better view. That curved piece of bronze on that mouse board on the left is just how that board bends. And then we can see it all fitted in there. So the components are stacked. The two gold pieces actually do hook together with a ribbon cable, even though they don't in the CAD view, but that's how they will fit when it is assembled. And that's how the buttons look on the outside. That hole in the middle, right between them, and down just a little bit, is for the scroller. If you put a 1/16 inch hex key in there, this compares the old brace to the new brace. Right there's the old brace. You can see it's still 0 degrees, and then that's the new brace. See how it's at an angle. That's a 20-degree angle. The bottom still fit the PCB board exactly the same way. And there you can see that angle better when it's matched up. Those distances between the levers are still the same, so it still fits the same way on the case. This shows our modified brace along with the PCB board and the case and that angle in there, that 20-degree angle. The other thing that you can also see on this, which is different, is that triangular cutout on the case between those two notches that fit into the front lenses. That's so it's easier to snap the Wouse into the front lenses. Lastly are two small tabs which shims can be put on. This may be critical if you have a large head and there is not enough room between your face and the laser. And here is the final version of the Wouse. 3D CAD printed hardware, all the parts, all assembled. Watch my next video for how you can build one when you have the parts.